The general topic is outlined in various ways. By review, I personally think taking a specific question will be misguiding. So if you find anything from the quizzes or whatever, you can ask.
Okay.
Like last night in the class, students, it was a different class, students asked so many talk questions. I ended up telling them, okay, there will be a talk question in the final exam.
Oh, shoot.
No, so that was,
Dang. I'm looking at electric flux. This is from the list of questions that you give us from Cengage 18. I think we might have done it in discussion, but I don't exactly remember. 'Cause I
by
don't have
18,
anything.
do you mean question number or?
Yeah, question number 18 from
Chapter 15.
sure.
No, 18 is not flux related.
No, okay, it's from week 4.
It's from week 4.
It's from week 4 of our
Okay.
discussion class, so I don't know exactly what chapter that would be.
Yeah, I can.
That wasn't electric flux.
Week 4, 18.
Is it not on there?
Not in week 4, but we'll in the previous week. It is not a 18. The flux was that week. So while I am searching, we still need to summarize, so just take a couple of minutes.
Okay. Actually,
It's chapter 16.
Yeah.
Oh, you found it?
No,
Oh,
no, go ahead. Chapter 16.
chapter 16, problem 18.
Okay.
Because I think it's like got 4 parts to it.
Do you see it? Can you read it? This is
Yeah.
18. I can try to make it a little better if you want.
Yeah, no, I have it written too.
Oh, which part?
Could we just do the whole thing?
Oh, sure. We can do the whole thing. And unfortunately, that's we have 2 charges. I'll probably not use the numbers, but just refer that one is positive, one is negative, one is double in magnitude than the other. Yet, if you do want some numbers as far as the negative charge goes, the negative charge is located at the origin and the positive charge is located at some distance in the positive side on the x-axis. I wrote negative 2q and positive 2q because first and foremost they are asking you to plot the electric potential as a function of distance 0.5. But regardless of what it is, for the negative charge, the electric potential always is going to be negative. For the positive charge, the electric potential is going to be positive. So these curves are of electric potential. But more important or interesting is, which probably the clue is in this part, find the symbolic expression for the potential on the x-axis at an arbitrary point between the two charges. So what helps is one of the charge being at origin, I'm going to take the arbitrary point to be at a distance x from the origin, and the total electric potential, these are numbers, is always going to be these two added together. So you may ask what is 1 and what is 2. I'm just calling these charges as 1 and 2. But this is just the general expression. In the next step, I'll have to use one number from the problem itself, but I can put it on the picture also. And the number essentially is where exactly the positive charge is. So that is 1.2 meter. Okay. And then I will go with the same suffix, just to put it as a general symbolic expression. Same suffix 1 and 2 for charge 1 and 2. So 1 is on the left, 2 is on the right, and we add the potential. But this is where probably the rest of the magic essentially is. K, charge 1 is negative 2q. We have the number for it, and we are going to find the potential at a distance x from the charge. So R1 is actually x. And for the next one, K, this is positive Q, and the distance of the point, this is where the 1.2 comes in, is 1.2 minus x. So this is the general expression for the potential at an arbitrary point P in between the two charges.
What, isn't x already 1.2?
No, x is something that I don't
So
know.
x, okay, so it's 1.2 to the x. Okay.
Yeah, this is 1.2 minus x. But this expression is very specific to part B. So let me confuse you even more with a part which is not here, and that is basically to say that what if someone asks you to find the electric potential way to the right, point P. So what will change? I'm using color to my advantage. Part C is actually asking you to find the electric potential exactly in the middle. So if this is part B, I'm trying to save time for other questions that you may have. And all you want to do is put x is equal to 0.6 in the expression 4. The electric potential, and eventually part D is setting this to be equal to 0 and find what x is equal to. And just because we have a graph, I can tell you that it is not exactly going to be in the middle. This positive and this negative, my drawing is freehand. They are not going to cancel one another in the middle. We are adding positive and negative. So expectation essentially is I will have to go farther away from the stronger charge and closer to the weaker charge. Oh yeah, in week 4, number 18. Okay, next.
Actually, I did think on the last test, test 3, questions 11 and 14, those were tricky. Brady got them right, but I know they spent a lot of time on them. So maybe if you could do those again, they could see where they got hung up. He did get it right, but I know she said that was challenging.
Which number did you say?
11 and 14.
Oh, something similar was worked out. Is this the question? A convex mirror produces a virtual image.
I believe it is, yes.
Oh. If you need to read it, I can try to zoom it up. On the other hand, we are given magnification being 3/5. That is what the image size is, and that also is where something else is needed. Convex mirrors gives us virtual images, which basically makes this as plus 3/5. We do need this information to go forward. So as far as question goes, it is what is the focal length and also what is the image distance. Both of these are going to come out from
equation, if I know two of them, I should be able to calculate the third one. So that's where, let's put the DU number that is there on the screen. The object distance is known, 65 centimeters, and we go to the, I am absolutely sorry. In our course, we use P's and Q's. Oh, sorry. So, magnification is negative Q over P. So that is 3/5. And with P known, part A of the answer, negative Q, is equal to 3/5 P or 3/5 of 65. You don't have to do the math in your head, but if you do, you will end up getting Q to be equal to negative 39 centimeters. And once I know what Q is equal to, we go to the mirror equation to calculate the focal length. Ah, 14 certainly is challenging. We do have two plane mirrors, and we found that the outgoing ray coming out at some angle theta 2, which is what we want to determine, with the incoming ray, probably the picture is telling you, is parallel to the second mirror. So let's start with the geometry first, and the incoming ray, because it is parallel to the second mirror, makes an angle with respect to the mirror as angle theta 1, but the law of reflection essentially tells me that the angle of incidence when measured with respect to the normal, so if we do draw a normal, we will find that this angle is 90 degree minus theta 1. Okay, since it is your question, if this angle is 90 degree minus theta 1 and this is 90 degrees, then this angle is also theta 1. So from here, one can go in any possible direction of choice, but I am going to take something geometric, which is to say that if I have these three angles, sum of the internal angles is 180 degrees. So theta 1 is given to us 66. So 2 times theta 1 is 132. You can use the calculator. So angle alpha is going to be 48. And rest of it is to say that with this being alpha, these angles being equal, this is also going to be alpha. So at least with the numbers here, it should be 48. Theta 2 should be 48.
Can we also look at 12? I know we've practiced it a lot.
I think we just did,
Did we?
or no?
That one.
Did you say 12? and-
No, we did 11 and 14. But yeah, let's do 12. That, yeah.
Oh,
I keep getting this one wrong.
you keep getting this one wrong?
Yeah, I do.
Oh,
I
no.
practice it a lot, but it's still
Okay.
lost in
Right.
translation.
Driving principle certainly is that the image due to the first lens is going to be the object from the second lens. So we have a converging lens to some distance left of the diverging lens, and the focal lengths are given to us, positive and negative. We also know where the object is
That's right.
as far as numbers go, just because they are referring to some x and y, or just x's, probably we just need to translate it in terms of being distances. So I'm going to start with the first lens, and the focal length is given to us as 4.5. Take a look where the object is. The lens is actually at x equals 0. The object is 1.6 centimeters to the left of the lens. That's why they used the negative sign. So for the first lens, I will not use suffix. P is equal to 1.6. Is this okay? And just to work through the numbers real quick, I'm also going to use my, I don't want to call it cheating formula, but the simplified version of the image distance. So focal length 4.5. You may have to help me with the calculator, and that is let me know. I can certainly punch it out. What is the result of 2.9? What is the result of this?
Negative 2.48.
Negative 2.48. So all this is telling me is that the image, this is 1.6, I'm not drawing a scaled diagram. The first image is at negative 2.48, and this is where the second lens actually comes in. For the second lens, the object is still to the left of the lens. I'm still using the same symbol P for object distance, and the object for the second lens is at 2.48 plus.
Look at the separation between the two lenses, 11 centimeters.
Everything so far is in centimeters. So for the second lens, the object is this far away. We are given that the focal length is negative 8.3. So for the second lens, Q is equal to, I'm using the same, so this is 13.48. I'm using the same simplified version to find what the image distance is going to be. And even without looking at the numbers, I can see that the image distance is going to be negative, so it is going to be to the left of the second lens.
I got negative 5.13.
So, with this being 11, the final image is going to be somewhere over here.
So the negative is determining where the final image is, whether it's to the right or to the left of the mirror, right?
Whether it is to the right or left of this secondary.
I think he got a little bit of points off on 13. He got most of it right, but not all of it. I'm pretty sure it was that one.
Yeah, I was the same way.
Okay. I think he inverted just like 2 things on one of them. But well, that's a long one.
For privacy reason, I cannot actually look up which part was incorrect, but usually by looking at responses, I can tell you, I can turn it off and look if you want.
Sure. We don't actually, I don't care if Alyssa sees, quite honestly. She maybe got the same part wrong.
I inverted the impedance and
You don't have to turn it off.
the resistance.
No, legally,
Okay, whatever.
I
Okay.
still.
All right.
Oh, I did the stupidest thing,
Oh no.
which is okay as long as I wait 2 minutes. I should have moved it away.
Oh, I see.
It will take time to
Re-
warm up.
Got it.
You remember the question number, right?
I think it was 13. Yes.
13.
Yeah.
Okay. So, I probably do know what your, or where possibly the mistake could have been, or number crunching wise. And
You can use Ohm's law to solve for resistance, right?
yes.
Because I think that's what I did. And I must have messed up my numbers or something.
Yours is going to where, starting from part C, answering the question. Although you do have
Yeah.
one comment that you should be careful about, and one comment being you appear to be calculating this correctly using incorrect answers from above.
Oh.
So that sometimes is what is the problem. So what happened to my student? So let me see if my projector turns on.
Did Brady get part D wrong?
And since you jumped into it, so that was direct XL minus XC divided by R gives you the phase angle. Tangent of the phase angle, you still have to take the tan inverse of it.
That's the one he got wrong, E?
Yeah.
Okay.
Your incorrect is probably very unfortunate, but everything stemmed from this one, and certainly I'm not yelling, but certainly if you look at correctly answering part A and part B, in part C you have a number that is lower than the numbers in A and B. You are squaring it and then square root and adding something to it. The moment you get that 1.71, which is lower than earlier numbers, you can recheck.
Yeah. I don't know.
Well, it's only 7 days that you have to know, but beyond that,
Right? Gosh.
I think that's all we have.
Did you look at the last one?
Sure.
Did you look at the last one? Just for funsies.
yeah, the last one is sort of modeled with one of the questions in the last 2 quizzes. I don't know exactly which one. But anyway, let's go backward. And backward is basically they are asking you to calculate the index of refraction for which the internal reflection will happen. So I know this is just to clean up clumsiness, but still, I said backward because for internal reflection to happen, it just starts happening when the ray grazes the surface. It comes out, but it comes out at an angle which is 90 degrees. And it's going happen when the ray is incident at the angle that we call the critical angle. So this is basically going backward. Keep in mind, this is where the light ray is coming from. So index of refraction, we don't know, we want to calculate. This is 1. So at this point, we are going to apply Snell's law. And if we do that, here is medium number 1, here is medium number 2. N times sine of theta c is 1 sine of 90 degree, which is also 1. But this is only going to give you the critical angle value. The index of refraction 1.52 is given to you. So sine of theta c is 1 over 1.52. Take the inverse of that, and we get the critical angle value. It is still where we need to continue going in a backward direction and eventually do some geometry, just some, because the ultimate goal is to find the angle theta 1. So once again, the geometry is, I claim it to be simple because this corner is 90 degree. So if you look at it, while I am calling this as theta 2, theta 2 is going to be equal to, because this is 90 degree, theta 2 is going to be equal to 90 degree minus the value that you calculate. So I claim that we know this as a number. You can do the rest. We apply the Snell's law again. So medium number 1, medium number 2, n of air, which is 1, sine of theta 1 is equal to n of the glass, sine of theta 2. So this is 1, and the rest of the numbers are actually known now. So once again, inverse sine is going to, I did this problem completely weird, not reading my own question. Or not seeing the pictures at all. I should quit. Anyway, I'm not.
Wait, no, he's not done yet.
What does the clock say?
No, he's fine. He heard the word quit. Sit down. He's fine.
He's very happy that I made a mistake.
Yeah, I think so.
Okay. Randy, you can have your laugh. Otherwise, everything else approach-wise is correct. And even the pictures are correct. So let me quickly correct it. As far as the correction goes, one correction is here, and that correction essentially is that we are given, this is 1.52, I did write that, but the outside is not air, oh sorry, the outside is some liquid whose index of refraction is 1.52, and we are trying to find out this n. So one correction is right here in that equation, n times sine of theta c is 1.52 times sine of 90 degree. We are still trying to find the n, and assuming that the internal reflection happens, and the other correction is right here, it is still coming from 1.52, so 1.52 sine of theta 1 is equal to n times sine of theta 2 . So those are the number corrections that I need to make because it is not here. There's possibly is still a question that you want to ask, which is, now that we have a complicated looking equation, how do I find all these things? N is sine of theta 2 to be equal to 90 minus theta c is still going to hold. And this is the part which is most challenging if you think about it, but somehow I think it falls under your prereq knowledge that sine of 90 minus theta is cosine of theta. But so we actually have that information somewhere in here. If you look at it, substitute, and we can calculate the value of n from here. Just trying to finish it in time, although specific student interest, so
we don't have review on Friday, right? This is the last lecture.
yeah, Friday is a study day.
Okay.
So the university expects you will be studying.
Yeah, it needs a study.
It will be interesting what happens Friday night and Saturday because there are final exams scheduled on Saturday.
Really?
Yep,
That's sad.
I know, but this is Wisconsin, you cannot avoid slush.
One last question. It's just about the grades. Will we be able to see like what our final grade is so we know what we need to get on the exam?
What your final grade is, short answer, yes, although it is not, I personally don't make it the first priority.
No, I mean before the exam, can we see how everything has been weighted so we can kind of figure out like what we need to get on the final to get a certain grade?
That's already there, so you probably need to sit down with some hot chocolate and open the green book.
Well, I looked at it, but it looks like you didn't drop
Looking at me.
one test. Did you drop the lowest test already?
I think I did.
Oh, because I thought it said out of 150 the other day. Did you? Because shouldn't it be out of 100 then if you dropped
The
one
other
test?
day- The other day is other day, IT updates happen in the middle of the night.
Oh, okay.
So,
Because we just looked at it yesterday and it still said 150.
okay,
Okay.
let's see what.
I guess I could look.
she says.
Then I guess I should look. Yeah.
She says,
Me?
Let me look.
what's there?
I'll look, Brady.
Yeah, look at it.
Yeah, I'm looking.
Pretty sure it's there.
Okay. Oh yeah, it did change. You're right. I know it's different than yesterday, so it's not letting me scroll down, but I don't know why. Here.
Did you drop the quizzes already? I still have all 3 of my tests on here.
Yeah, the scores are there, but one of them may have and phone is not the best, but
Yeah, phone's probably not the
may have a
best.
small cross mark next to it.
Gotcha. I see now. Wow.
Wow.
Wow. Just crazy.
Yeah, it's not letting. The total is different than yesterday, so you must have changed it. Okay. But it won't let me go and see that everything. It's not letting me scroll. But okay.
Yeah, mine's glitching out too.
Because the final's 30%, right?
Yes, it is.
Okay.
Can I find a stand-in for me?
That day is coming. That day is coming, and someday the university will realize that having a consolidated final exam really does not verify
Yeah.
whether someone. And I have done many things in past. I can do those things again. With final being the only thing that is mandated by the university, I have gone through a whole semester, no homework, no quizzes, nothing,
Just a final.
just the final. And
How did that go? I'm
the
curious.
amount that you are shaking now, I'm just assuming you were shaking.
Yeah.
That semester, students were shaking 100 times more.